Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, and welcome back to our class. And actually, this is a recorded topic. And yep, today we are going to uh, discuss a new topic. But actually, it's not a standalone topic because this topic will have a connection, yeah, to our previous uh, topic, yeah. Okay, so today, okay, so before I start my lesson, I just want to say that this video will be divided into some parts. Yeah, so if I stay recorded this from the initial point after the end session of this topic, then this video will be very long. So I think it will be better for us, yeah, and also for me actually to divide this recorded into some parts, yeah. And also I hope that you can be relaxed, yeah. I mean, you can take a rest in between the videos, yeah. Okay, now topic for today, yeah, we are going to talk about something called the parabolic motion, yeah, parabolic. Nah, parabolic motion. Okay. Okay, so as we know that there are a lot of kinds of motion, yeah. We have um, strike motion, yeah, and also we have another kind of motion called parabolic motion, yeah. So what is parabolic motion, yeah? What is it, yeah? Okay, so as the definition, um, actually it's hard for me to tell you about the definition, yeah. But the parabolic motion is motion like this, yeah. So let's say uh, there is a person and he throw a ball, let's say a basketball, and this is the basket, yeah, and this is the basket. This is the basket ring, and this person try to put the ball into this point, yeah. So he throw the ball, yeah. And the trajectory or the path of the ball will be, yeah, will be something like this, yeah. Oh, I'm sorry, will be something like this. Yeah. No. Will be like, yeah, yeah. So some kind like this, yeah, yeah. So the the projection, I mean, the trajectory or the path of the ball will look like this one, yeah, yeah. So it's like a pen, yeah, and this condition can happen, yeah, due to the gravity, yeah, because we have gravitational force. So the ball, yeah, so the ball, so this ball, yeah, so the ball. Yeah, so the ball will have a path like this, yeah. Yeah, will have path like this, yeah. Okay, and this can happen because the interaction of the ball and the gravitational force, yeah, because the gravitational force has direction into the center of the earth, yeah, which is, let's say, moved downward, yeah. Yeah. So so the ball will be like this, yeah. Uh, but if we, let's say you go into the space and you try to throw the same ball, yeah, the ball will not have a path like this, yeah. But um, the ball will be uh, go into the space, yeah, like this, yeah, because in the space we don't have any gravitational force, but because we are living on Earth, yeah, we are living on the surface of the Earth, and we have gravitational force, so the path will be like this, yeah. Okay, so this is the definition of a parabolic motion, yeah. Maybe you have your own kind of definition, but actually all the definition will be similar with what I have drawn here. Yeah. Okay. So this is the definition. Yeah. Okay. And now, what is the application? So where in which sector we can apply this kind of motion? Yeah. Actually, a lot of things there, a lot of area that we can apply this concept. Yeah. The first one is in sport. Yeah, as I mentioned before. Um, let's say you want to be a professional basket player, and you use the concept of physics, yeah, to make your throwing, yeah, so precise, yeah. So you use some kind of physics calculation, so your ball will be hit into the perfect point of basket ring. Yeah. So that sport. Yeah. But I think when you have good feeling, yeah, I think you don't have to use any calculation to throw the ball. So the ball can be can enter, yeah, can enter to the basket ring. Yeah. Yeah. So it's in sport, but actually this calculation will be very helpful if you are working in a military sector. Yeah. So this application. Yeah. Application in military sector, yeah. So because in military sector you are going to deal with a lot of uh, balet, yeah. I mean in bahasa Indonesia we say peluru, yeah. And let's say you are operator or maybe the engineer that design tank, let's say, yeah. So let's say this is the tank, yeah. I'm sorry for bad drawing. Yeah, and this is uh, the direction of the bullet. Yeah, and let's say this is the target. Yeah, so this is the target, and let's say in between the tank and the target we have some kind of, let's say, building. Yeah, let's say the building here. So we have, yeah, so we have a building. Yeah, so this is a building. Yeah. So because you want to hit the target on this point, and you cannot destroy the building, so the only thing that you can do is make your palace, yeah, uh, throw. You have to throw the bullet, yeah, above the building, and at the certain point, yeah, the bullet will move downward and finally hit the target. Yeah. So you have to make your bullet have, I mean, has the project path of bullet in this way. Yeah. Nah. So this is also the use of parabolic motion concept, yeah, in military. Yeah. But actually we have a lot of application, yeah, not only in sport and military, but I assume that this kind of concept will be always used, yeah, in military, yeah, because sometimes you have to direct, yeah, your rocket or maybe your pilot, yeah, to hit the target, but you have to uh, pass, yeah, pass the certain object, let's say a building or maybe even bigger. Yeah. Let's say this is a mountain here. Yeah, we have mountain in this point, so you have to make your pilot move above the mountain. Yeah, yeah. So it's interesting. Yeah, when you are able to apply the concept of physics in your working habit. Yeah. Okay, so that's the simple introduction of our topic today. Okay, now let's talk about the calculation. Yeah, the calculation that we are going to use in uh, uh, the concept of, yeah, some basic calculation that can help us to solve the problem of parabolic motion. Okay, okay, but before we go there, I just want to you remind that uh, in this session, yeah, we are going to deal with a lot of velocity. Yeah, no, I mean mostly we are going with velocity. So, uh, sorry, yeah. So velocity, yeah, or in bahasa Indonesia we call it with kecepatan. Nah, and velocity uh, is kind of vector, yeah. As we know that in quantity we have two kinds of types. Yeah, um, the first one is scalar quantity, and the second one is vector. Yeah, so velocity is kinds of vector. Yeah, so it will have value and also direction. Yeah. Okay. So in physics, yeah, in the concept of physics, if we um, if we are dealing with a vector which has directions, we can also divide. Yeah, we can also divide the vector into its component. Yeah. So uh, in direction, yeah, we can how to say ya, menguraikan ya. I'm sorry, I don't know uh, the English of menguraikan ya. Wait a minute, what is this? Oh no. Okay, so menguraikan ya. Wait a minute. Ah, to it's hard ya. But actually, in bahasa Indonesia, what I mean is menguraikan ya. So I will use um, decompose or yeah, whatever. Yeah, so we can divide, yeah, the vector into its component, yeah, to its component, yeah. Okay, so let's say um, I have uh, nah, let's say this one is x-axis and this one is y-axis, yeah. But I'm sorry, my drawing is not good, yeah. So actually, this one is a perfect line, but due to a very not stable, unstable hand, I have something like this, yeah. But I believe that you got my point, yeah. Okay, so yeah, let's say I have vector here, yeah. So I have a vector which is velocity, yeah. So this one is velocity, and the value is, let's say, 10 meter per second, and the direction is like is as what you see on the screen, yeah. So it's go to this direction, yeah. Okay, and now this velocity, yeah, makes an angle, yeah, makes an angle with the x-axis, yeah. Let's say the angle is in theta, yeah. So this one is theta, yeah. And the theta is equals to 30 degree, yeah. And the v, yeah, which is the velocity, is 10 meter per second. Okay. Now this v is what we call it with VR, yeah, which is v resultant. Yeah. So this one is VR, yeah. So VR stands for the v, yeah. The v stands for velocity. Meanwhile, the R, yeah, the small r, I mean the subscript R symbol stands for resultant. Yeah, resultant. Nah, because this one is resultant, yeah. So actually, yeah, the velocity itself, yeah, is a combination of its component. Yeah. Okay, so I will repeat it again, because this one, this v, I mean um, this velocity is vr. Yeah, we have, which is r stands for resultant. So actually, the vr, yeah, is combination, yeah, between its component. Yeah, and the component of, yeah, the component of vr, yeah, is, yeah, the first one is vx, yeah, which is the component of vr in x-axis, and also the second one is vy. Yeah, so um, this velocity can be decomposed. Yeah, we can divide the velocity, the r velocity, into its component, which is vx and also vy. Yeah. Okay. So for simplicity, then I will change the color. So for the vx, I will use blue color, and for the y, I will use green color. Okay. Okay, now we are going to know the value of this component. Yeah, the value of this component. The value of Vx, yeah. Okay, let me change into blue. The value of Vx, yeah, it is the x component of Vr, yeah, is Vr. Vr is red, yeah. Vr times by sin, yeah. Not sin, but cos. Yeah, cosinus. So we are going to use basic concepts of trigonometry. Yeah, in this topic. So the reason why I choose cos, yeah, cos here, because um, the known angle, yeah, sudut yang diketahui, yeah, is in space, yeah, in space between the VR and the component of the axis, ya. Jadi kenapa saya menggunakan theta, menggunakan cos theta, ya, karena theta ini diapit, ya, diapit oleh kecepatan dan komponennya, begitu ya. Nah kalau ini kan berbeda ya. Kalau di sini kan eh, sudutnya tidak tertulis gitu ya, tidak tertulis secara eksplisit atau tidak tertulis secara langsung, sehingga eh, saya tidak menggunakan sinus theta tapi menggunakan cos theta, karena ketika V2 ini akan saya uraikan menjadi komponen ke sumbu X, tetanya adalah diapit gitu ya antara resultan dan aksisnya. Oke, okay, so that's the definition in bahasa Indonesia ya. Oke, okay. So cos theta. Oke, okay, so VR. Yeah. So the value of VR is 10. Yeah. And then the value of cos theta, I will use a bracket here. Cos theta, which is theta is 30 degree. Yeah. So let's use. So actually, you can use a calculator, yeah, but because I don't have. I mean, I'm not bringing my calculator with me, so I will use online calculator. The Yeah. So this one is my favorite online calculator, but it's up to you if you have more other preference of Simulab, other preference of online calculator, you can just use but you know, yeah, what you get. But for me, personally, I love to use this one. Okay, let's say uh, 10, yeah, 10 cos 30, and don't forget to put degree, yeah, because if you only put 30 without degree, then your answer will not be accurate, yeah. Okay, 10 times cos 30 degree, and then go. Okay, now what I have is uh, decimal 8.99, yeah. So there are two answers actually. The first one is 5 square root of 3, and also the other answer is 8.66, yeah. But actually these two answer is similar, yeah. The first one is using a square root symbol, but the other one is use a decimal symbol, yeah. But for me, I prefer to use decimal, yeah, the decimal answer, so 8.99, yeah. Okay, 8.9 8.99, yeah, meter per second, yeah. So 8.66 meter per second is the value of x component of v resultant. Yeah. So if I draw into this line, into this coordinate axis, then I will have some kind like this. Yeah. Yeah. Okay. So this one is Vx. Yeah. 8.66 meter per second, yeah. And this one is the direction, this one is the component, yeah, the component of uh, v resultant, yeah, in x component. Okay, now if we have x component, it will also have uh, Y komponen, ya. Jadi kalau dia punya X komponen, ya, apalagi kalau dia miring seperti ini, ya, pasti dia juga memiliki komponen di Y, gitu ya, di komponen di Y. Ya. Jadi kita tidak hanya mencari yang komponen X, tapi we have to also find um, the value of Y component. Yeah. Okay. Now let's talk about let's find the Y component. Yeah. We use VR, but this time we multiply the VR with sin, yeah, sin theta, yeah, because we want to we want to decompose the VR into this axis, yeah, into this y axis, and we don't have explicit number of theta here, yeah, but actually the value of angle here is 60 degree, yeah, because the y because the y and x axis makes a 90-degree, yeah, of angle. Yeah, so 90-degree when we have 30. Yeah, then we have 30. So this one must be 60. Yeah, but in this case we don't have any explicit information. Yeah, so we can just assume that we don't have any information of angle in this point. So we use sin theta. Yeah, but in this case, yeah, because we have directly uh, explicit information of angle, which is 30, so we use cos. But in this case, yeah, we don't have a specific value of angle, so we use sinus. Yeah. So VR times sinus theta. Yeah. Okay. Then I will use, so VR, the value of VR is 10. Yeah. Times sin, uh, very bad. Sin theta, yeah, which is 30. Yeah. 30 degree. Yeah, okay, so you can use your calculator, but I will use this one. Sin, yeah, 10 times sin is 30 degree. So what we have, so it's only 5. Yeah, the answer is only 1, and it is 5. Yeah, without any square root or something. Yeah, it's directly 5. Yeah, so I will put the number 5 here. Yeah, so 5 meter per second. Yeah, so in this case, yeah, I will write, yeah, yeah, the Vy is 5 meter per second. Yeah. Okay, so I will make a conclusion here. So actually, we have in initial condition, yeah, we have VR, yeah, as our initial, as our resultant of velocity, yeah, which is the value of VR is 10. Yeah? But when we have to decompose the velocity, the resultant, the resultant velocity, then we will have two kinds of component. Yeah, the first one is the component in x-axis, and then the other one is the component in y-axis. Yeah, and through our calculation with very simple trigonometry, actually we have two components here. The first one in x-axis, which is the value is 8.66 meter per second, and then in the y-axis we have 5 meter per second. Yeah, so this one is the component, yeah, of the VR. Yeah. Okay, now it's the component, yeah, the component. So after we know how to decompose the after we know how to decompose VR into its component, now we try, yeah, now we try to combine it again, yeah. We try to combine its component because actually when we have the value of its component, yeah, the picture will be like this. Yeah. The real picture, yeah, very bad. Wait a minute. Yeah, yeah. So uh, the picture will be something like this. Yeah, will be. So I think I have to. Okay, so I will just draw the velocity, yeah, without any coordinate line. Yeah, so this one is this one is the Vx, which is the x component of VR, and then uh, Very. Yeah. So I'm sorry for very bad. I don't know why. I think I have my problem with my hand. Yeah. So this one is the uh, actually I have to use green. Yeah. So this one is nah. Yeah. So actually the real picture is like this. Yeah. And I will not draw this one. Yeah. The reason is because it has been decomposed ya into the component ya. Jadi kenapa kok di gambar yang ini saya tidak menggambar yang warna merah ini ya? Saya tidak menggambar yang warna merah ini karena sudah kita pecah gitu ya. Kita pecah menjadi komponen-komponennya. Nah, yaitu di sumbu X dan di sumbu Y ya. And after this we are going to try ya to combine it again ya. We try to combine it again from its component into uh, the resultant yeah, because we have to also know yeah how to decompose and to combine yeah, not only just to decompose but also how to combine um, into a new yeah, into a new resultant of velocity yeah. But I think I have to postpone this video first, and I will continue to second part of this topic. And thanks for your participation until this video, because after this we have still another video.